Good day, so this is the group 1 reporting. So the following members are Aligado Wing Cyrus S, Asio Charles Matthew O, me myself Basco Denny E, and Bation Per John Louis P. So our course are MTEC 102, so we are in midterm, week 1, session 1. So the topic is marine compass and magnetic variation. Course outcome. So the course outcome is to know the brief history of marine compass and the discovery of magnetic variation with the computation of the correct of the variation. So the magnetic compass was first invented as a device for divination as early as the Chinese Han Dynasty and Tang Dynasty, since about 206 BC. So the compass was used in Song Dynasty China by the military for navigational orienteering by 1040 to 1044 and was used for maritime navigation by 1111 to 1117. So historians think China may have been the first civilization to develop a magnetic compass that could be used for navigation. Chinese scientists may have developed navigational compasses as early as the 11th or 12th century. So Western Europeans soon followed at the end of the 12th century. So the first known determination of magnetic declination was made by the Chinese in about 720 AD. In Europe, the concept of declination was known in the early 1400s, but the first precise measurement of declination was not made until 1510 when Georg Hartmann determined the declination in Rome. So next is the learning outcome. So the learning outcome is at the end of the session, the student shall be able to understand the relevance of marine compass in navigation and how to compute the correction of magnetic variation. So the magnetic compass was an important advance in navigation because it allowed mariners to determine their direction even if clouds obscured their usual astronomical cues such as the North Star. So it uses a magnetic needle that can turn freely so that it will always point to the North Pole of the Earth's magnetic field. So magnetic declination is important because it is the amount of degrees a compass must be shifted so that its needle is pointing towards true north. So we need to calibrate our compass so that it compensates for the angle between magnetic and geographic north, referred to as declination. So this allows us to use the compass needle which point at magnetic north to navigate along a path reference to true north.
Importance of the topic. The difference between these two north points is known as magnetic variation. This movement is unpredictable, so if your map is old, the information on it may not be correct. It is therefore important to research the magnetic variation for the area you are visiting before setting off. Ever-Chuty's treasure fleet of Dragon Throne governed the whole South Pacific and the Indian Ocean between 1405 and 1433, a territory that stretched from Korea and China to eastern coast of Africa. Of navigational application of the magnet. The first treatise on the magnet itself was written by Petrus Peregrinus de Maricourt, the Magnet, during 1269, and though its nautical use was already mentioned in 1187 by English monk Alexander Neckham, the use on board only came about around the 13th century and 14th century in the Mediterranean Sea. The Spanish canonical work on the marine compass navigation, or Arte de Navegar, was written in 1545 by Pedro Medina. This masterwork was originally translated into Dutch in 1580 and implemented by Jacob Hemskerk. When Dutch annihilated the Spanish Armada around Gibraltar 1607, Van Hemskerk's death during the victory was undoubtedly disadvantage.
In the fin cycle of 16th century, mariners believed that magnetic North Pole coincided with the geographic North Pole. Any suggestion otherwise had been decided by Pedro de Medina. Magnetic observation made by explorers in subsequent decide shown whenever that these suggestions were true. But it took until the early 19th century to pinpoint the magnetic North Pole, somewhere in Arctic Canada, 78 degrees north, 104 degrees west. From then on, the angle between the true north and the magnetic north could be precisely corrected for. This correction angle called magnetic variation or magnetic declination. It is believed that the Earth's magnetic field is produced by electrical current that originate in the hot liquid outer core of the rotating Earth. The flow of electric current in this core is continually changing, so the magnetic field produced by this current also changes. This means that at the surface of the Earth, both the strength and direction of the magnetic field will vary over the years. This gradual change is called the secular variation of the magnetic field. Therefore, the encountered magnetic variation not only changes with the location, but also varies over time. The correction for magnetic variation for your location is shown on the nearest nautical chart. Compass rose. In this example, we find a variation of 4 degrees 15 miles west in 2009 with an indicate annual correction of 0 degrees 04 miles east. In 2011, this variation is estimated to be 3 degrees 59 miles, almost 4 degrees west, and for 2020, the estimate is 2 degrees 47 miles west. This means that if we sell 19 degrees on the chart, i.e., the true course, the steering compass will read 94 degrees in 2009 and almost 93 degrees in 2020. The true course is often shown as COG, course over ground, or CMG, course made good, on your GPS plotter. Another example, let's say the compass rose on the nautical charts give a variation of 2 degrees 15 miles east in 2019 with a correction of 0 degrees 04 miles east per year. In 2021, this variation is estimated to be 2 degrees 58 miles nearest 3 degrees east. If we sell 90 degrees in the chart, the steering compass will be read 87 degrees. A paper of digitized nautical chart can feature multiple compass roses. Use the nearest one to obtain the magnetic variation.
On the right illustrates the difference between the true north and the magnetic north when the magnetic variation or var is 10 degrees west. From the image we find TC is equal to CC plus var, in which CC and TC stands for compass course and TC is for true course respectively. To convert a true course into a compass course, we need first assign a blank to a western and a blank to an western variation. Note that this makes sense because of the clockwise direction of the compass rose. Here, the inner circle is turned 10 degrees anti-clockwise, hence negative 10 degrees. Now, use the same but rewritten equation. CC is equal to TC minus var. 235 is equal to 225 degrees minus negative 10 degrees. So, to sail a true course of 225 degrees, the helmsman has to steer a compass course of 235 degrees. To convert a compass course into a true course, we can use the original equation. If we have steered a compass course of 200 degrees, we have to plot a true course of 203 degrees in the chart if the variation is 3 degrees east, or a true course of 190 degrees if the variation is 10 degrees west.